In this lecture, we discuss about the fourth test of the given series, which is called comparison test. Let us first define what is the meaning of comparison test. Let sum of un and sum of vn be two series of positive terms such that the limit of the ratio of nth term of first series divided by and second term, that is un upon vn when n tending to infinity, which is equal to some finite non-zero number, then both the series converge or diverge together. This is called comparison test. So in case of comparison test, this is very simple. Its meaning is very simple. We have to compare the two series, and then we are able to get that the given series is convergent or divergent. Now let us take one example so that it will clear. So example number 1, test the convergence of the series sum of root of n divided by n square plus 1. Now, in the given example, we have only given the one series. And now if we want to apply the comparison test, we need the two series. So here we don't have two series, we have only one series. So how to solve this question using the comparison test, and how to find the another series which can be obtained with the help of the given series. First thing, where we apply the comparison test. Very simple answer of this question is, if the nth term of the given series, just look here in the numerator and in the denominator, it is in terms of polynomial. Just look here, in the numerator, root of n, it means n to the power 1 upon 2, and in the denominator, n square plus 1. So now, if the nth term of the given series is containing the algebraic term, then we apply the comparison test. The given series is sum of un is equal to sum of root n upon n square plus 1. Here, nth term un is equal to root n upon n square plus 1. Therefore, the nth term of the auxiliary series, sum of vn is given by. So from this series, we are able to get the auxiliary series, which can be obtained. Vn is equal to, nth term of the auxiliary series Vn is equal to root of n upon n square. So how we are able to get it? So for getting n term of auxiliary series Vn, we have to first take what is the highest power term in the numerator. So now in the numerator, we have only one term, root of n. So we have taken only the root of n in the numerator. Similarly, what is the highest power of the n square of the term or of the variable n is n? It is n square. So we write down n square. So if you want to find out the auxiliary series of any given series, we have to only take the highest power of the variable. Like here, the highest power of n in numerator root of n. Similarly, in the highest power of n in denominator is n square. So we will write down root of n upon n square. Now, if we can write down root of n is 1 upon 2. And now if we take in the denominator 1 upon n square minus n square minus 1 upon 2. And if we simplify is 2 to the 4, 4 minus 1 upon 2. So 4 minus 1 is 3 upon 2. Consider now, so we have, this is the auxiliary series, sum of Vn is equal to 1 upon n to the power 3 by 2. Now, as we know that in case of comparison test, we have to first find out what is the ratio of un upon Vn. And after finding the ratio, we have to calculate what is the limit of the given ratio when n tending to infinity. Here un is equal to root of n. upon n square plus 1, and Vn is equal to 1 upon n to the power 3 by 2. Let us just simplify it. So we have to first write n upon root n upon n square plus 1. And this n to the power 3 by 2 will goes to numerator and 1 comes to denominator. Now again, n to the power 1 by 2, n to the power 3 by 2 divided by n square plus 1. If you multiply n to the power 1 by 2, n to the power 3 by 2, it is nothing but n to the power 1 by 2 plus 3 by 2, which is equal to n to the power 4 by 2, which is equal to n square. Here n square is written. And now in the denominator, if we take n square common from the denominator, what we are getting? 1 upon 1 plus 1 upon n square. So the given expression, this expression is converted into this form. N square will cancel. Now if you put n equal to n tending to infinity, 1 plus, this is 1 upon 1 plus 1 upon infinity, and 1 upon infinity is 0. So we are getting 1 upon 1, which is equal to 1. And clearly 1 is the non-zero finite number. So in case of comparison test, if we want to apply the comparison test for this series, we have first obtained the auxiliary series Vn. Then the second step, we obtained what is the value of limit of un upon Vn when n tending to infinity. We also obtained it is 1. So according to the comparison test, both the series will converge or diverge together. Now, by P series test, auxiliary series sum of Vn, which is equal to 1 upon n to the power 3 by 2, is nothing but the P series, where the value of P is equal to, if we compare with the P series, the value of P is equal to 3 by 2, which is greater than 1. Therefore, by the P series test, the above series, which series? Auxiliary series, is convergent series. Now, since the given series, the auxiliary series is convergent, and summation and limit of un upon Vn when n tending to infinity is some finite number, and hence both the series will converge or diverge together. But auxiliary series converge because P is equal to 3 by 2, which is greater than 1 by using the P series test. So therefore, the given series will be also convergent, right? So given series un is also convergent. Thank you.